The Tunguska Event, which occurred in Siberia in 1908, is one of the largest and most mysterious natural events in modern history. Estimated to be approximately 1,000 times more powerful than the atomic bomb dropped on Hiroshima. This explosion devastated a vast forest but left no conventional impact crater. This paradox, incredible destructive power, yet zero physical evidence, has captivated the scientific world for decades. Was it an asteroid, a comet, or something more exotic? In this video, we will explore the striking story of Tunguska step by step. From the earliest expeditions to today's cutting-edge research, from the most accepted scientific theories to the wildest conspiracies, we will examine every aspect of this extraordinary event. What could be the truth? Let's begin. June 30th, 1908. Tunguska, a remote corner of Siberia. At around 7:15 a.m., the sky seemed to split in two. First, a dazzling ball of blue light, brighter than the sun, emerged. Then, one of the greatest natural phenomena in recorded history took place. An explosion so powerful that it flattened 2,000 square kilometers of forest like matchsticks. But that was when the real mystery began. Not a single crater, not even a single meteorite fragment was ever found. Even today, over 100 years later, we are still trying to unravel the mystery of the Tunguska Event. The epicenter of the explosion was in a nearly inaccessible area, farther than St. Petersburg. Fortunately, no one lived there. The force of the explosion is estimated to be equivalent to 10 to 15 megatons of TNT, almost 1,000 times the force of the atomic bomb dropped on Hiroshima. The shock waves circled the globe twice. Weather stations in Europe recorded seismic waves. That night, skies in Siberia and Europe were so bright that people said they could read newspapers at midnight. 19 years later, in 1927, Soviet mineralogist Leonid Kulik became the first scientist to reach the region. After a challenging journey, the sight he encountered was incredible. In the area known as the flattened forest, trees had receded from the center outward like sunbeams. What Kulik was looking for, however, was a giant crater and iron and nickel fragments. But all he found was swampland and destruction. The expected crater was missing. This deepened the mystery even further. Kulik and others thought a giant iron meteorite had struck the ground. This should have left a massive crater, but there was nothing. So what could account for such enormous energy, but not create a crater? The answer lay in the atmosphere. The main body, 5 to 10 kilometers below the ground, broke apart under the immense pressure and heat and exploded in the air. It was an airburst. Its energy radiated down into the forest, so it didn't create a crater. In the 1970s, the theory of a cometary fragment rather than a meteorite gained traction. Comets are made of ice, dust, and rock. This perfectly explains why there was no crater. The ice would have completely evaporated in the atmosphere. Furthermore, examinations of trees in the area found microscopic silicate and magnetite globules with a structure similar to that of comets. This became one of the strongest pieces of evidence supporting the cometary theory. Another theory, as powerful as the comet, is that a relatively loosely structured, stony asteroid is responsible. This object, which lacks a solid structure like iron meteorites, disintegrated upon entering the atmosphere. This disintegration triggered an explosion that released enormous energy. Current computer simulations confirm that a stony asteroid 50 to 60 meters in diameter could have caused this impact. This is one of the most widely accepted scenarios today. The mystery has spawned more exotic theories. Some have suggested a black hole passing through Earth. Others have suggested a rare antimatter particle was converted into pure energy upon contact with normal matter. A more localized theory is that a large amount of natural gas leaked from underground, causing an explosion. However, most of these theories have not gained much acceptance in the scientific community because they are not supported by existing evidence or cannot fully explain the observed effects. Today, researchers have much more advanced technology to find the answer. Satellite imagery, LiDAR scans, and georadar devices are probing the area down to the millimeter. Sediment cores taken from the marshes are searching for anomalous spaceborne chemical signatures in the layer dating back to 1908. These modern methods are helping us pinpoint the precise angle and height of the explosion, as well as clues about the object composition. In the early 2000s, an Italian research team examined Lake Cecco, 8 kilometers from the eruption center. The lake's shape and depth were unusual. Sonar scans revealed a dense, compact object at the bottom of the lake. Was it a surviving fragment of the eruptive object? However, later studies suggested the lake might be older than the eruption. Lake Cecco remains a possibility, but it remains far from definitive. It remains a mystery. Tunguska wasn't unique. On February 15, 2013, a 500-kiloton airburst struck the Russian city of Chelyabinsk. Although much smaller than Tunguska, it injured more than 1,500 people and caused millions of dollars in damage because it occurred over the city. Chelyabinsk reminded us how real and present this threat is. An event the size of Tunguska has a probability of occurring only once every 100 to 200 years. So how do we manage this risk? The answer lies in planetary defense. Institutions like NASA and ESA are running projects to detect and track near-Earth objects, NEOs. NASA's DART mission has proven that we can change the orbit of an asteroid. Our goal is to detect the next Tunguska, or larger one, hundreds of years in advance, and deflect it harmlessly. Every gap left blank by scientific explanations is filled with conspiracy theories. Tunguska was no exception. One of the most popular theories was that one of Nikola Tesla's experiments in wireless energy transmission went out of control. Another, even more fantastical, was that an alien craft, whether an unintended visit or an explosion, detonated. These ideas, combined with the Cold War's veil of mystery and the growing interest in UFOs, cemented Tunguska's place in popular culture. However, they lacked any concrete evidence. Tunguska has become an indispensable part of science fiction and mystery stories. The most iconic example is the episode Tunguska from the X-Files, in which Mulder and Scully travel to the region to investigate an alien virus. Strategy games, adventure games, and novels have used the name to add depth and a realistic air of mystery to their stories. Tunguska is no longer just a geographic location. It has become a universal symbol of the unexplained and the secret. So what is the true legacy of Tunguska? This isn't just conspiracy theories. It's a scientific awakening. Tunguska was the first modern, large-scale warning, reminding us that Earth is not a closed and secure system, but rather vulnerable to the dynamic and sometimes dangerous forces of the universe. This event laid the foundation stone for near-Earth object research and the concept of planetary defense. It marked the beginning of a path from Leonid Kulik's simple instruments to the giant telescopes that monitor asteroids today and missions like DART that can alter their orbits. The mystery of Tunguska may never be fully solved, but perhaps that's the real point. It's a reminder of the surprises nature still has to offer and the endless puzzles science awaits. As we scan the skies and try to protect ourselves, we must not lose the primal awe and wonder we feel in the face of this colossal force of nature. Like the flowers that sprouted anew from the ruins of Tunguska, this mystery should inspire hope in us. Hope to understand the universe, to grapple with it, and to never lose our wonder. Because the search continues.